Hello and welcome. My name is Mr. Asprey and this is 2022 Mechanics Maths A Level by EDEXCEL. And if you do like my content, please do drop a like and subscribe. That would be fantastic, much appreciated. And let's get into it because I absolutely love mechanics. So I'm super excited about this. Okay, question number 1, and we have vectors and we have motion. And my trigger for this question to figure out what I'm going to be using is the fact that there is a t in the vector equation. And that means that it is variable acceleration, or variable in this case velocity. Which means that it's not going to be constant acceleration, which means that we cannot use SUVATs, we have to use instead integration. Find the speed of p at the time when t equals 2. So I can find the velocity first by substituting in 2. So I'm going to get 2 squared I minus 6 2 to the power of a half j. So this is going to give me 12i, and it's going to give me minus 6 root 2j. Now that's the velocity, it's not the speed. And the speed is the magnitude of the velocity. Which means I need to take the square root of the components squared. So I'm going to square 12, and I'm going to add that to 6 root 2 squared. So that's going to go into my calculator, and I'm going to write the square root of 12 squared plus in brackets 6 root 2 close brackets squared equals, and that is 6 root 6. Doesn't give me a particular degree of accuracy, so I'm just going to leave it in exact form, meters per second to the minus 1. And that's question A done. 2 marks in the bag. Lovely jubbly. Find an expression in terms of t, I and j for the acceleration. Okay, so I know it's variable velocity, so I'm going to remember PVA. If you're a football fan, you might think of the footballer Patrick Van Aanholt. And what this does is, this stands for position, velocity, and acceleration. And we differentiate down and we integrate up. So if I want to work out the acceleration, I need to differentiate. Now when I use PVA, or differentiation or integration with vectors, I always like to write my vectors in column form. I find it much easier and I'm much less likely to make mistakes, so I'd recommend it. So 3t squared and minus 6t to the half. And we don't need to write the i's and j's because the position or where they are in the column tells us which direction they're moving in. Okay, so now in order to work out the acceleration, we differentiate down the velocity. So this is going to give me 6t, and that's going to give me a half times 6 is 3, so it's minus 3 t to the minus 1/2. And it's absolutely fine to leave your answer like that. Oh no, it's not actually, because it does actually say an expression in terms of ij. So I would have to convert that back into ij form. So I'll do that, but very easily just by writing out the top column, or the top row, sorry, as the I, and the bottom row as the J. Okay, now we're asked to find a position vector at t equals 1, and we're given the fact that at t equals 4 the position vector is given to us, which is going to be useful. Okay, now how do I find position? Well, position is the top here, so I have to integrate the velocity up in order to work out the position. So the position, which we notate R for some reason, I'm not sure, baffles me every time. We need to integrate the velocity. So again, I'm going to write it in column form because I find it much easier. So I'm integrating 3t squared minus 6t to the half with respect to t. Okay, so let's do the top one. Up the power to 3, divide by the new power is going to give me t cubed. But as always, we need to add on a constant, and I'm going to call that constant c. And here we're going to up the power to 1, so 3 over 2, and 6 divided by 3 over 2 is 4, so we're going to get minus 4 t to the 3 over 2, and again plus a constant. Okay, next step is to work out what that constant is, and we do that by using the initial conditions or the boundary conditions, which I'll highlight in green here. T equals 4 and the position vector is 1 minus 4. So we write the position vector is 1 minus 4, and that happens when I substitute in t equals 4. So 4 cubed plus c and minus 4 times by 4 3 over 2 plus d. And again, the reason why I'm doing this in vector form, it makes it so much easier to figure out these constants. So 1 is equal to 64 plus c, and minus 4 is equal to, well, 4 rooted is 2, cubed is 8, times by 4 is minus 32 plus d. So now we can see that c must equal minus 63 and d must equal 28. Okay, so my position I can now write again as a column t cubed minus 63 and minus 4 t to the 3 over 2 plus 28. And what am I been asked to do? I'm asked to find the position vector when t equals 1, I believe. Yes, t equals 1. Well, just sub in t equals 1. And we're going to get 1 minus 63, and we're going to get minus 4 plus 28. So we will get minus 62i and plus 24j meters. And we are done. Okay, question 2 says that we are on a rough plane, which means there'll be friction, and it also says that tan alpha is 3 over 4. So I'm going to start by drawing a quick diagram here. Alpha, tan is opposite over the adjacent, and by Pythagoras that will be 5. So that tells us that cos of alpha is equal to 4 over 5 and sine of alpha is equal to 3 over 5. Okay, some of the forces, we've got mass, we've got this x newtons, and we've also got the reactional force of 68.6. So let us draw a good force diagram. The first force we're going to draw is the weight, which is 5g. I'm then going to draw the components. So I'm going to start at the start of the force and draw a perpendicular line down like that, and then I'm going to carry that line on by drawing a perpendicular line to that line in that direction. Now I know that the angle will always be the same as the slope, and that angle is looking directly at the red line here, so that's 5g sine alpha because it's opposite the angle. And the green one will be 5g cos alpha because it's adjacent to the angle. Next I'm going to look at this Z force. It's not acting parallel or perpendicular to the slope, so I'm going to have to take components again. So first off, what is this, let's just start at the start of the angle like I did before. I'm going to draw a dotted line perpendicularly down, and then I'm going to draw one perpendicular to that line across, and we should have drawn arrows from the start all the way to the end of the force. Now what angle is this in here? This is also alpha. I know that because I could draw a Z like this, and we should know from GCSE maths that alternate angles are equal. And now this alpha is pointing at and is opposite the green line, so this is Z cos alpha. Sorry, it's not Z, X, sorry. And this is X. Oh, sorry, confused myself. That is X sine alpha because it is opposite, obviously. And this one is adjacent, so this is X cos alpha down there. Okay, still got some more forces to add on. The normal reactional force, which we were told was 68.6. And finally, friction. Now this question is a bit tricky because we're not actually sure which way friction works, because this force here is keeping the object in place. Now it could be pushing really hard that the object is about to go up the slope, and if that was the case, friction would be acting down the slope, stopping it from doing that. Or it could be acting quite softly on this object, only just holding it, only just stopping it slipping down the slope. And in that case, friction will be acting in the other direction because friction always opposes motion. So I don't know which way the friction is going to be going. So what I'm going to do is I'm just going to guess. And if I get it right, great. And if not, well, I'll be able to know, and I'll explain why in a second. So I'm just going to guess it's going that way simply because I don't want to draw a force going the other way because my diagram looks so neat. Okay, so those are all the forces. So let me zoom out. And let's now answer the question. And the question is, find the magnitude of the frictional force. Okay, well, the frictional force is acting perpendicularly to the, in parallel to the slope. And I know that the frictional force is going up, and so is X cos alpha. And what's going down is 5g sine alpha, so they must be balanced because it is in equilibrium. So that's equal to 5g sine alpha. So I know everything that I don't know x, so that's going to be a bit of an issue. So let's see if we can find x by looking in the other direction. Okay, so in the other direction, I'm just going to get rid of this. We have going upwards 68.6, and we have going down x sine and 5g cos. So those must be equal. So going down is x sine plus 5g cos. Okay, we can solve now for x. So x is equal to 68.6 minus 5g cos alpha all over sine alpha. Okay, so I can go to my calculator and I can write that we have 68.6 minus 5 times 9.8 times cos alpha is 4 over 5, and that's over sine alpha, which is 3 over 5, and I get 49. So x equals 49. So now I can go to this equation and I can write that f is equal to 5g sine alpha minus x cos alpha, and I can write in my calculator 5 times 9.8 times sine alpha is 3 over 5 minus x, which is 49, times by cos alpha, which is 4 over 5. And I get an answer. I get a negative answer. So here we go. Okay, well, what does that tell us? It tells us that the force is going in the wrong direction. So when I drew my diagram, I drew the friction in the wrong direction. But that's fine. I now know that. So I can write my answer is 9.8. And the direction is down the slope. Uh, 9.8, and that would be newtons. Okay, so now it says the horizontal force is removed and B moves down the plane. You've got the coefficient of friction, find the acceleration. Okay, so I'm going to have to mess up my lovely diagram. And what's going to change? Well, x is going to disappear, so all of that's going to go. And so is x as well. So get rid of u. And now the frictional force is actually going to be working that way because the object's sliding down the plane, so friction is going to be opposing it. But the reactional force will change because it's no longer it no longer has this force acting against the reactional force, so it will change. Okay, so the reactional force will need to be calculated again. And that's our new force diagram. Okay, so let's get rid of this so we can do my working around the force diagram. And the first thing you notice is let's find the reactional force. Well, just by looking at the diagram we can see that it must be balanced with 5g cos. Okay, and now we know what the frictional force is, because we know the frictional force is mu r, and 0.5 is mu, and r is 5g cos. Okay, so let's do a F equals ma now, in order to work out the acceleration. So the sum of the forces is equal to the mass times by the acceleration, and the sum of the forces is that we are, well, first off we know we're accelerating this way, so let's make that the positive direction. So we've got 5g sine alpha going in that positive direction, and we are taking away the frictional force, which is 0.5 times 5g cos alpha, and that is equal to the mass times by the acceleration. So to find the acceleration, I will need to do 5g sine alpha minus 0.5 times 5g cos alpha all over the mass of 5. Okay, great. To save some time, divide by 5, divide by 5, divide by 5. So in our calculator needs to go 9.8 times sine. I've rubbed out my sine triangle, but we know that it was 3 over 5. Minus 0.5 times 9.8 times cos. And cos being, cos was 4 over 5, equals 1.96. Perfect. The acceleration equals 1.96. And we are done. Okay, question number 3, and we have some forces here, and we have a mass of 4 kilograms is at rest. That's important. Smooth horizontal plane at t equals 2, two forces are acting, and given that P moves in this direction, show that lambda minus 3 mu plus 7 equals 0. Okay, so first off, I'm going to draw a quick diagram. It's going to move 3 in that direction and 1 in that direction. So it's going to be going off in this overall direction. So that means that the force needs to be applied in that direction in order to make it accelerate in that direction. So the total force are the two forces added together. So again, I'm going to do this in vector format. So the sum of the forces is equal to 4 minus 1, and by vector format, so I mean column form, plus lambda plus mu. So I could write that as 4 plus lambda minus 1 plus mu. And we need the i's to be 3 times the j's in order for us to go in this direction. So I need the i's to be 3 times the j's. So I need the i's, which is the top row, to be 3 times bigger than the j's. So if I times the j's by 3, then we should get equality, because the i's are 3 times bigger, so if I times the j's by 3, they'll be equal to each other. And then it's just a case of simplifying and getting it to the form which they have asked for, which is all on this side, plus 7 equals 0. Really straightforward question, that one. For 4 marks, I think it's very generous. Next, less so straightforward. At t equals 4, P passes through the point B, and given that lambda equals 2, find the length. Okay, so we know that the force is proportionate to the acceleration, and there's no t in any of these forces, which means that all of these forces are constant. And that means the acceleration is constant, and that means we can use good old suvat. Okay, so if we have variable, we use PVA. If we have constant, we use suvat. Now we know that lambda equals 2, so we can use that to our advantage by writing 2 minus 3 mu plus 7 equals 0. So therefore 9 minus 3 mu equals 0. So 3 mu equals 9 and mu equals 3. Okay, and we know we've got to use constant acceleration, and we know that the sum of the forces is equal to the mass times by the acceleration. We worked out the sum of the forces previously. We now know what lambda and mu are, so we can write the sum of the forces is 4 plus 2 and minus 1 plus 3, so 6, 2. The mass we were told was 4, and that's times by the acceleration. So the acceleration is equal to 6.2 divided by 4, which is 1.5, 0.5. Great. So let's set up a suvat, because again it's constant acceleration. So we know the acceleration, 1.5, 0.5. The time we are told to investigate at t equals 4. We were also told initially that the object was at rest, so that's going to be useful. and we want to work out the length of AB, so the distance it's travelled, which means we're not going to use V, which means we're going to use S equals UT plus a half AT squared. Now U is 0, so the UT part we don't use. A half times by the acceleration of 1.5, 0.5, times by T, which is 4 squared. Okay, so let's say that S is equal to, calculator out, 0.5 times 1.5 times 4 squared is 16, gives me 12. And a half times 4 squared is 4. So the distance it's travelled, or the length from A to B, is equal to the square root of 12 squared plus 4 squared, which is equal to the square root of 160, or you could write that as 4 root 10. And we're done. Okay, another question where we need a good old force diagram. So a uniform rod, which means the mass acts through the centre, and the mass is m, so therefore the weight is mg. And this particle C has mass of 2m, so therefore the weight is 2mg. And it's held up by a string, so there is tension here. And the floor is rough, so the frictional force is going to be acting like this. And the reason why that is, which is actually the first question, is because, well, let's first do our forces, our components. So I'm going to do a component of all of the forces because we're going to need the parallels and perpendiculars to the ramp, and also just the ups and downs, the horizontal and the verticals. So first off, I could draw a little dotted line down here, and then one going across this way. And again, the angle in here is always the same angle as the slope. So therefore the red one is mg cos, because it's next to the angle adjacent to it. And this one here is mg sine, because it's opposite the angle. And again, I'm going to do this one here, dotted down that way. This is going to be 2mg cos theta by the same logic. And this one going across is going to be 2mg sine theta, because that is theta in there. I'm also going to do the I'm going to do some components for the t as well. I'm going to do the vertical, and I'm going to do the horizontal, like such. Now, what is that angle? That's not as obvious. So what I'll do is I'll draw a horizontal line across like that, and we'll know from Z angles or alternate angles that this in here is theta, because we have this Z here with theta down the bottom. So therefore this angle in here is 90 minus theta, which means this angle over here is theta. So that angle that we're looking at there is theta. Great. Okay, so this one adjacent is t cos, and this one opposite is t sine. And the last thing to add is the reactional force here at the base of the rod. And we are complete. That's our force diagram done. It looks fantastic, and I know that it's taken a long time and we haven't actually answered any of the question yet, but it's so important to draw a good force diagram. It makes the rest of the question so much easier. Now it says explain why the frictional force is acting on the rod at A acts horizontally to the right. And that's because the only horizontal forces is T sine theta, which acts to the left. So therefore, friction must act to the right to balance it. Okay, so the reason why is to balance T sine theta acting to the left. Okay, now we need to show that the tension is equal to 2 mg cos. So I'm going to take moments at A, and the reason why is because I don't want to include R and F. I don't know what they are yet, so I want to cancel them out. So I'm going to write here moments at A, make it clear to the examiner they know what I'm doing, and I am going to look along the rod. I come to my first force, I look down perpendicularly, and that is mg cos. And that is a distance of A away. So I multiply mg cos by A to get the moment. And then the next one I do is I go along and I hit my next force, again perpendicularly, and that's 1.5 distance away. It's going in the same direction, so it's going to be added on. That's 2 mg, and that is cos of theta, and that's times by 1.5 is the distance A. And we go again. I'm going to go across, hit my next force, and perpendicularly is just T, the whole of the tension, and that's going in the opposite direction, so therefore these things must balance, and that is 2 lots of A, T. And we're good. I really don't know why they say A, because what's the point? Why don't you just say meters? Because the A's are going to cancel, so let's just divide through by A, get rid of that. It's a waste of everyone's time. So T is equal to, well, we can collect up terms here. We've got 1 mg cos and we've got 2 mg cos times by 1.5. So that is a total of 4 mg cos. Sorry, that's still 2t. So therefore t is equal to half of that, which is 2 mg cos. And that is what they've asked us for. Okay, so it's given that cos is equal to 3/5, show the magnitude of the vertical force exerted by the ground at A. So we're looking for R. Okay, so we are going to just do the sum of the forces in the vertical. So let's look at the vertical direction. We have R going up, and we also have going straight up is T cos. And what do we have going down? We have mg and 2 mg. So that's a total of 3 mg. There we go. So just grab some space. R is equal to, let's just do this down here. So we had R plus T cos is equal to 3 mg. So R is equal to 3 mg minus T cos, and we know that T cos is 2 mg cos cos. Because remember, T we worked out before was 2 mg cos. Okay, great. So let's go to our calculator. And first, actually, let's just factorise an mg. So we've got 3 minus 2, and cos is 3 over 5, and 3 over 5. Okay, so we can do that calculation. We should get 3 minus 2 times 3 over 5 times 3 over 5. Perfect. That's 57 over 25 mg. And now it's asking us to find the coefficient of friction. So, yep, we can do that. And we are just going to resolve horizontally this time. So we've resolved vertically before. Let's now resolve horizontally. And our force is already highlighted in blue there, nice and conveniently. So friction is equal to T sine theta. Okay, fantastic. So friction is equal to T sine theta. We already knew that cos theta was equal to 3 over 5. So cos is the adjacent over the hypotenuse, 3 over 5. So by Pythagoras this is 4, which means that sine theta is 4 over 5. And we also know that T from before was 2 mg cos, and cos is 3 over 5, times by sine is 4 over 5. Now, what is friction? Remember, friction is the coefficient of friction multiplied by the reactional force. And we know what the reactional force is. It is, well, we've just did it in the question before. The reactional force is this one. So we can write mu multiplied by r, which is 57 over 25 mg is equal to 2 mg 3 over 5, 4 over 5. The mg's will cancel. So mu is just equal to 2, 3 over 5, 4 over 5, all divided by 57 over 25. So to the calculator we go, and we have 2, 3 over 5 times 4 over 5, all over 57 over 25, and we get 8 over 19. Fantastic. Okay, we have a golf ball which is at rest. The ball is hit initially and moves at an angle of alpha, and then the ball hits the floor again 120 meters away. We know that the initial speed is u, and it says show that u squared is equal to u squared sine alpha cos alpha is equal to 588. Okay. So with any projectiles question, the best thing to do is to set up a horizontal suvat and a vertical suvat. The horizontal, well, for both of them we have suvat like this. And as always, the acceleration in the horizontal is always 0, and the acceleration in the vertical is always minus 9.8. And what do we know? Well, the only point which we can inspect is this point right here, because that's the only one we know any information about. And at that particular point, the horizontal has travelled 120, We know that the whenever something is projected like that, we have u, and then we have alpha, so therefore this is u cos alpha, and we have going upwards this way u sine alpha, because again there's the alpha there and it's looking, the opposite is sine, and the one that's next to the adjacent is cos. So we have for the vertical u sine alpha, and for the horizontal u cos alpha. Now we also know that the times are going to be the same because we're analysing the same point. And we know that on the vertical it's going to go back down to 0, because it's going to go up and then back down to 0 vertical. So we can get rid of the v's and we can use our good old trusty formula, s equals ut plus a half at squared. So let's do that first for the horizontal, and we get 120. We're going to get u cos alpha capital T, and there is 0 acceleration, so I don't need to add on the at squared. And now let's go for the vertical. We have s is 0, and that's equal to u sine alpha t minus a half of 9.8 is 4.9, and t squared. We're now going to combine the two equations, and I'm going to do that by making t the subject of this equation on my left, and then I'm going to replace the capital T in the equation on the right for the vertical in order to eliminate t. So we're going to get 0 is equal to u sine alpha multiplied by 120 over u cos alpha minus 4.9 120 over u cos alpha squared. Okay, let's simplify this by writing that as 120 u sine alpha over u cos alpha minus 4.9. Let's do that calculation. 4.9 multiplied by 120 squared. Okay, that's 70,560. So that's going to be on the top, 70,560. And on the bottom, well, when I square a fraction like this, I have to square the numerator, which I've already done, and square the denominator as well. I'm going to get u squared cos squared alpha. Okay, my next step then is to multiply both sides through by u cos alpha. Oh, sorry, no, not that. I'm going to use u squared cos squared alpha. That's going to be easier. So I'm still going to have 0, because multiplying anything by 0 gives you 0. And I'm going to have one of the u cos alphas cancel, so there'll be another one on top. So I'm going to get a u and a u, so a u squared on top, a sine alpha and a cos alpha. And over here I'm just going to get this 70,560. And then I'm going to make this the subject by pushing it over to that side. And then finally I'm going to divide through by 120, and I should get that 588. Fantastic. As required. I'm now asked to analyze the ball when it reaches the maximum height of 10 meters above the ground. Okay. And then, sorry, it says show that u squared is equal to 1960. So maximum height means I need to look in the vertical direction once again. And I'm told that the maximum height is 10. The initial velocity is still the same, and it was u sine alpha in the vertical. Now the velocity at that particular point, when it reaches its maximum height, is 0, because when a ball goes up in the air, it will stop before it comes back down again. So maximum height always means that v is equal to 0 in the vertical. Acceleration is always minus 9.8 in the vertical, and t, I don't know what the time is, but I don't think that's going to be necessary because we've already got 4 bits of information there. Okay, so that means we need to use v squared is equal to u squared plus 2as. V is 0, u squared is u squared sine squared alpha, and 2a times by 10 is 2 times minus 9.8 times by 10 is minus 196. Okay, so 196 is equal to u squared sine squared alpha. Now this isn't quite what we need. In fact, what we have is we need to find u squared on its own. So I need to get rid of that sine alpha. I've also noticed that I've got another expression which involves u squared. So I'm going to use both of these two in order to find the expression which I've been asked to find. So if I pair that up with 588 is equal to u squared sine alpha cos alpha, then, I mean, ideally I need to work out what alpha is, because if I work out what alpha is, then I'll be good to go, and that will give me the equation that I need. So I'm going to write, I'm going to rearrange for u squared. So in the first equation I get 196 over sine squared alpha, and in the second equation I get 588 over sine alpha cos alpha. Now because they're both equal to u squared, it means I can eliminate the u squared and set them equal to one another. So 196 over sine squared alpha is equal to 588 over sine alpha cos alpha, and then multiplying both sides by sine squared is going to give me 588 sine squared over sine cos, and we can cancel, so divide through by sine alpha is going to give me this, and we know that this is equal to, well, a sine alpha over cos alpha is equal to a tan alpha. So we have 196 is equal to 588 tan alpha, which means that tan alpha is equal to 196 divided by 588, which is 1/3. Great. Now whenever I have a value for tan or for sine or for cos, I need to convert it into a different value, a different trig function. I'll just do a little triangle like this. So tan is 1/3, so it's the opposite of the adjacent, which means by Pythagoras 3 squared plus 1 squared is 10, so it's root 10. And what I'm looking for is sine alpha. Again, I'm looking for sine alpha because then it means that this equation will give us exactly what we want. So sine alpha in this case is 1 over root 10. And in fact, I was looking for sine squared alpha, which will therefore be 1 over 10. And because of that, I can then take this equation down here. 196 is equal to u squared sine squared. So 196 is equal to u squared times 1 over 10. So 1960 is equal to u squared as required. Great. And a lot of work for this. And that question was not easy. That was not an easy question. It's not obvious at all. So don't beat yourself up if you didn't get that right first time. It then says that there's a new model, and we are now looking at air resistance, and the new initial velocity is capital V. So state which is greater, V or U. So V is greater than U, and that's because we have to overcome air resistance. So if you need to throw an object just as far as you did before, but this time you've got air acting against you, then you're going to have to throw it harder. So that's why V is greater than U. And one other model refinement, well, you could say the shape of the ball is considered, or you could say the spin of the ball. Those are the two classic ones other than air resistance. And we are done. I hope you enjoyed that, and I hope that it was very helpful. I've got lots more papers. I've got 2020, 2021 and 2022 now all completed, so please do check them out. The playlists are just here, and if you have not already, I would appreciate it if you could like this video and subscribe. I've got lots more content coming out, so all of those things would be very much appreciated. Thanks very much, and bye for now.